The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, eventually, we're going to go on and take a look at section 14.2, but first I have a bunch of information to remind you of and to give you, et cetera, et cetera. Okay, so the first thing is we have a math center that you can reach through a Zoom meeting. Here are the hours of operation: Sunday 3 to 9 p.m., Monday through Friday 10 a.m. to 4 p.m., Monday through Thursday 6 to 9 p.m. There is the Zoom ID, and if you don't have time to write it down now, you can always go back and view the video, okay? So the Math Center is available to help you during these hours. Now, I want to remind you of a couple things that I did mention to all of you, but some of you long ago and you've forgotten. The way that I want you to get in touch with me is through email, not through text messaging, not through phone calls. I had people calling all day yesterday, okay? And I don't respond to phone calls. I want you to email me. Now, if I don't get back to you in a timely fashion, go to the Math Center, because I had, like I said, I literally had phone calls all day long yesterday. And I know I don't have much of a life, but I have a little life. So I will respond to your emails in time. Ideally, this is what you should be doing, okay? The day that the assignment is assigned, that is the day you work on it, not the next day at the last minute when it's due, that day. Then if you have questions, you can email me and say, hey, Mr. Mayo, can you do these on your video the next morning on your Zoom meeting? Or if I have time, I will get back to you that day. But what's happening is I've got students that aren't coming to the Zoom meeting, which is why this may even be a waste of time. Maybe I'm talking to the people that are doing the right thing and the other ones will never know because they never come. But the idea is that if you can't come to the live meeting, you are to watch the YouTube video first before you start asking me questions. Because most of the questions that people are asking me, then I'll say, have you watched the video? And they're like, no. Well, if you'd watched the video, you'd know how to do that stuff, okay? I've got 96 students, so you've got to watch the video before you ask me questions, okay? Now, again, this is the Zoom meeting ID. So write that down. And if you don't have time right now to write that down, like I said, you can come back and watch the video. Again, a reminder, my YouTube channel is Math with Mayo. The playlist is Math 93 Fall 2021, and that's where I'll be. Okay, having said all of that, let's take a look at a question. In fact, two different people requested the same question, but the numbers are slightly different, so we'll do both of them. Now, first of all, I'm going to deal with the numerator, and I'm going to take 8 minus 5, which is 3. So now I've got 5 factorial times 3 factorial over 4 factorial times 7 factorial. Okay. What I want to do, and this is where I think some of you that were having questions, you're just punching this immediately into your calculator. And so you get this big long decimal answer and WebAssign goes, nah, I don't want that. The only time you would do that is if you've got just a single large factorial, like 42 factorial, punch it in, get an answer. But with this, we're going to simplify it and reduce it down to a fraction in lowest terms. Okay. Now, I could take the 5 factorial and the 4 factorial and reduce things down. I could take the 5 factorial and the 7 factorial and reduce things down. I could take the 3 factorial and the 5 and the 4 factorial and reduce them down, or the 3 and the 7. But what I want to do is I want to get rid of as much as I can. So what I'm going to do is I'm going to deal with these two. And then I'm going to come back and I'm going to deal with these two. All right. So the 5 factorial over 7 factorial, I'm going to do this. In fact, I'm going to go down here so I have enough room. I'm going to have 5 factorial on the top and 7 times 6 times 5 factorial on the bottom. Okay. Then I'm going to take the 3 factorial on top and the 4 factorial on the bottom, and I'm going to have 3 factorial on the top. Bop, that's a combination of top and bottom. And then I'm going to have 4 times 3 factorial on the bottom. So what I've done there is basically I'm going to have a 1 in the numerator when I'm done. Notice the 5 factorials will reduce down to 1 over 1. The 3 factorials will reduce down to 1 over 1. So now on top I've got 1, and on the bottom I've got 4 times 7 times 6, which is 1 over, calculator time, 4 times 7 times 6, 168. Any questions about how I did that or why I did certain things the way I did? The idea was to get rid of as much as I could at the beginning. All right, we're going to do another problem, and it's going to be pretty much the same idea. So this is going to give me 6 factorial over 9 minus 6, which is 3 factorial, 5 factorial times 8 factorial. So I'm going to put those together and put those together. Why? So that again, I can get rid of everything on top. So that's going to give me 6 factorial over 8 times 7 times 6 factorial, and then 3 factorial, 5 times 4 times 3 factorial. All right, so the 6 factorials reduce out, the 3 factorials reduce out, and I'm left with 1 over 5 times 4 times 8 times 7, which is 1 over, let's see here, 5 times 4 times 8 times 7 is 1,120. And there you have it. Again, any questions about what I'm doing there? All righty. Well, we're going to go ahead and go on to section 14.2. And today we're going to look at arithmetic sequences. Arithmetic sequences. Okay. Now, back when I was in the classroom and I was teaching Math 50, which is arithmetic, often the assignments that I would give my students is I would say, I want you to do every other odd problem in this section, starting with problem number 1. So basically you would do 1, you'd skip 3, you'd do 5, you'd skip 7, you'd do 9, you'd skip 11, you'd do 13, you'd skip 15, you'd do 17, etc. Okay, so you're going to do every other odd. So the odds would be 1, 3, 5, 7, 9, 11, but you're doing every other odd. So you start with 1, you skip 3, you do 5, you skip 7, you do 9, you skip 11, you skip 13, etc., etc. So that would be what their assignment would be on up to however far the numbers in the assignment went. Okay, well, basically, this is an arithmetic sequence. And so I want to go through and kind of analyze it and see if we can develop a formula to use in general. All right, some notation. In fact, let's go back and let's do this. Let's get rid of these ones that we're not going to include. Okay. In a arithmetic sequence, a general name for the terms is A sub n. So A with a little subscript of n. The n stands for the term in the sequence. So this would be A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, etc. In general, it would be A sub n. Any questions about that? All right. Now, let's see here. What is the difference between the first and the second term? So if I take the second term minus the first term, what do I get? What's 5 minus 1? It's 4. What's 9 minus 5? It's 4. What's 13 minus 9? 4. 17 minus 13 is 4. So we say the common difference for terms in the sequence is 4. And we use the letter D to stand for the common difference. Okay. Again, any questions so far? All right. So this term is a sub 1. This second term is a sub 1 plus what? 4, right? Do you see how I'm getting that? It's the first term plus 4. Any questions there? Okay. This third term is a sub 1 plus 4 times 2, because there's a 4 and a 4. This next term is a sub 1 plus 4 times 3. This next term is a sub 1 plus 4 times 4, etc., etc., etc. Okay. In fact, I just realized something, so I'm going to change the way I'm writing this just to make it more consistent with how the formula looks. This is 2 times 4, 3 times 4, 4 times 4, and you'll see why in a minute. I could also come in and I could say this is 1 times 4. You might think, why would I bother to put it there? But again, it's important. So can you see that the first term, 1, is a sub 1? The second term is 5, but that's also the first term plus 1 times 4. I know this is a lot to take in this time of the morning. The next term is the first term plus 2 times 4. The next term is the first term plus 3 times 4, etc., etc. Okay. Now, we said the general term was a sub n. So for the first term, n is 1. For the second term, n is 2. For the third term, n is 3. N is 4. N is 5, etc., etc. Okay. So the first term is a sub 1. The second term is a sub 1 plus n minus 1 times d. Now, where am I getting all of that? Well, remember, d was the common difference, so that's this 4. And for this term, n, since it's the second term, n would be 2. This number right here is n minus 1. This number right here is n minus 1. Now, if I've got you totally lost, don't panic. That's just sort of an explanation of where the formula comes from. And the formula looks like this. Okay, where a sub n is a specific term that we're looking for. It's equal to a sub 1, that is the first term, plus this n right there, minus 1, times the common difference. Now, let's go back to our list. It's 1, 5, 7, 9, 13, 17, 19, 21, 25, 29, 33, 35, 37, 40, 39, 41. Okay. Let's see. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would be a sub 11. Okay. So the 11th term in the sequence is 41. All right. I got there by just counting it. But let's find it a different way. A sub 11 would be a sub 1 plus n minus 1 times d. A sub 11 would be a sub 1, which is 1, plus n minus 1, which is 11 minus 1, times d. Remember, the common difference was 4. Okay, so a sub 11 is 1 plus, let's see, 11 minus 1 is 10, times 4, which is 1 plus 40, which is 41. Now, you might think, well, shoot, why go to all that trouble? I could just write them all out here. Okay. Let's say that I want you to do your assignment in this given class here that I'm using as an example. I want you to do the starting with problem 1, every other odd, and I want you to do the first 50 problems. So my question is, what number of problem are you going to stop at? So basically, I want to know what a sub 50 is. What's the 50th term in that sequence? So it would be 1 plus 50 minus 1 times 4. Again, using this formula, which is 1 plus 49 times 4, which is 1 plus, let's see, 196, I think 11636, which is 197. So basically you do 1, 5, 9, 13, blah, 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 all the way up to problem 197. Okay. Any questions at this point?
It'll always be 1.
Sorry?
First, the A with the 1 on the bottom, will always be 1 where you start?
It will be the first term, but the first term may not always be the number 1. It's just in this particular sequence, the first term is the number 1. Okay, so A sub 1 is the first term, but A sub 2 is the second term, so it's a 5. So in other words, this number and this number aren't always going to be the same. Did you freeze there? I think you froze. You can't see it. Okay.
So
Let
you
me
could
do-
have a problem that starts with like the sequence starts with like 2 or 3 or something, and then you would just change the formula. Instead of 1, it's a 2.
Yeah, okay. Tell you what, let's do this. Let's say we're going to do every other odd, starting with problem number 3. Okay. So 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23. Okay. Now A sub 1 is 3. A sub 2 is 7. A sub 3 is 11, because the first term is A sub 1, regardless of what number that is. Okay. Whatever the first term in the sequence is, that's A sub 1. Okay with that? Well, we'll find out. Okay, we're going to look at some problems here.
That makes sense now. Thank you.
Good. Because that's my story and I'm sticking to it. All right. Now, here we have a situation. It says, write the first 5 terms of each arithmetic sequence with the given properties and find the specified term. Okay, we are told that the first term is 3 and the common difference is 2, and we are to find the 10th term. Okay, the first term is 3, the common difference is 2, find the 10th term. Now, in the directions, it said, find the first 5 terms of each arithmetic sequence. So the formula we're going to be using is A sub n equals A sub 1 plus n minus 1 times d. Okay. Now, they want the first 5 terms. And then they want the 10th term, because the direction said, write the first 5 terms of each arithmetic sequence with the given properties and find the specified term. Okay, so the common difference D equals 2. That's given in the original problem. The first term is 3. That's also given. So A sub 1 is 3. Now, if you take any term in the sequence and subtract the previous term, you get 2, which means the common difference between a term and its previous term is 2. But going up, you're going to be adding 2. So 3, 5, 7, 9, 11. Because A sub 2 is A sub 1 plus D, A sub 3 is A sub 2 plus D, A sub 4, etc. Are you okay with that? I'll take that as a yes. Now, I could use the same pattern and write out A sub 5, A sub 6, A sub 6, A sub 7, A sub 8, A sub 9, A sub 10. But what if I ask you to find A sub 212? You wouldn't want to do that all out. So I'm not going to do that to find this term. I'm going to use this formula. So A sub 10 is equal to A sub 1, which is 3, plus n minus 1, but in this case, n is 10, times the common difference, which is 2. So I'm taking the formula. I'm looking for this term, A sub 10. I know A sub 1 is 3. N is the subscript of the term I'm looking for, and D is the common difference. So this is equal to 3 plus 9 times 2, 3 plus 18, 21. So here's the first 5 terms, and here's the term they ask us to find specifically. Any questions about this particular problem?
If you wanted to check your work on it, would you just count backwards using your common difference?
You could do that. So 21, let's see, 19, 17, I mean, or count forwards. But again, I mean, that's not a wrong idea, but what if I ask you to find A sub 212? Are you going to count backwards and do all that? No. So you want to get used to this formula. Yeah, it's not. So to check that, doing it the long way would be a hard thing to do. Possible, but not a good method to use just in general. Okay. All right. Let's see here. Again, we want the first 5 terms and then a specific term. It says the first term is 8, and the common difference is -5. We're to find the first 5 terms, and then the 25th term. Okay. So the first term is 8. The common difference is -5. So A sub n equals A sub 1 plus n minus 1 times D. Okay. Now, recall from the last example, to get from the first term to the second term, we just kept adding the common difference, right? So what's 8 plus -5? It would be 3. What's 3 plus -5? It would be -2. What's -2 plus -5? It's -7. What's -7 plus -5? It's -12. Okay with that? All right. So A sub 25 is going to be 8 plus 25 minus 1 times -5, which is 8 plus 24 times -5, which is 8 plus, let's see, that would be -120. So that's going to be -112. Okay. And let's see. Yeah, we'll go on to the next. Any questions on that? Okay. This says the first 3 terms of an arithmetic sequence are shown below. Find the specified term. So a sub 1, a sub 2, a sub 3. Let's see, let's do this one. 2, 6, and 10. And we are to find the 28th term. Okay, so the first 3 terms of an arithmetic sequence are shown below. Find the specified term. Since it's an arithmetic sequence and they haven't told us otherwise, we're going to use this formula. Okay. Well, this is different from the previous problems in that we don't know right off the bat what D is. We do know that a sub 1 is the number 2, but again, how do we find the common difference? We take any term in the sequence minus the previous term. What's 10 minus 6?
4.
What's 6 minus 2?
4.
So we know that D is 4, right? Okay. So a sub 28 equals 2 plus 28 minus 1 times 4. Again, I'm just filling in, I know what that is, I know what that is, and I know what that is, filling that into the formula. 2 plus 27 times 4. 2 plus, let's see, that's 80 and what, 108. So that's 110. So the 28th term is 110. Any questions on this?
No, sir.
All righty. Let's see how we do it. Okay. Another example. It says, write the first 5 terms of the arithmetic sequence with the following properties. Okay. The first term is 5. And the 5th term is 29. Okay, now the reason I wrote it out this way is because it said write the first 5 terms. So I need a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. They told us the first term was 5 and the 5th term was 29. Okay, that's a funky looking 4 there. All right. Arithmetic sequence, so I'm going to use the formula a sub n equals a sub 1 plus n minus 1 times d. So I don't know what d is, and I do know the beginning one though, right? Let me ask you this. What is the date? All right, what day of the week is this? What day of the week?
It's Thursday.
Thursday. So today is Thursday. All right. That's kind of an equation. Today equals Thursday. All right. If you wanted to think of it that way. What is the date today? Today is what day of the month? It's the
23rd.
Is it the 23rd? By golly, it is. All right. So today is Thursday. Today is the 23rd. Therefore, we could say Thursday is the 23rd. If today equals Thursday and today equals the 23rd, then Thursday equals 23rd, the 23rd. Does that make sense? Hopefully it does, because that's the logic we're going to use. All right. What do I know? I know that a sub 5 equals 29. That's given right here. But I also know that a sub 5 equals a sub 1. I'm going to use the formula now, which is 5 plus n minus 1, which is 5 minus 1 times d. So I'm using the formula on this second statement, plugging in a sub 1 that I know and n that I know. Are you okay so far with how I got those two statements?
Yes.
So if a sub 5 equals 29, and a sub 5 equals 5 plus 5 minus 1 times d, therefore 29 equals 5 plus 5 minus 1 times d. Today is Thursday. Today is the 23rd. Thursday is the 23rd. So my equation becomes this. I now have an equation with one variable, d, so I can solve for d. 5 minus 1 is 4, 4 times d. I'm going to subtract 5 from both sides. 24 equals 4d. Divide by 4, d equals 6. Now that I know d equals 6, 5 plus 6 is 11, plus 6 is 17, plus 6 is 23, plus 6 is 29. So it checks. Any questions about what I just did here? Because this whole thing of coming up with two different ways of stating something to create an equation is a big piece of what we're going to be doing in today's homework. All right. Let's take a look at another example of that. If I could only talk. Let's see here.
Will numbers in the sequence ever be fractions, or they're always going to be like whole numbers?
They will be fractions. Yeah, sorry about that. It's a broken world we live in. It's just full of fractions. Okay, you're not smiling. Come on, smile. Fractions are our friend. Yay.
We're smiling in the inside.
Exactly. I knew that.
And crying in our brains.
Right.
Oh, okay. Write the first 5 terms of the arithmetic sequence with the following properties. The first term is -4. The sixth term is -39, but they asked us to write the first 5 terms. And they said, let's see, the sixth term is -39. This reminds me of something else in WebAssign. In WebAssign, if they ask you to do something and you put more than what they ask in the answer, they're going to mark it wrong. Let's say, for instance, the question said, write the first 5 terms, and you wrote the first 6 terms, it doesn't recognize it and it says wrong. And then you're like, but what I put down there is true. So read the directions carefully. It's not meant to trick you, but it doesn't think, it just responds to what it asked you. Okay, now, really, this is no different from the last problem in that, using this formula, okay, we know that a sub 6 is -39 because it's given. We also know that a sub 6 equals a sub 1, which is -4, plus n minus 1, which is 6 minus 1, times d, which is the common difference. Okay. But since a sub 6 equals that, and it also equals that, then our equation becomes -39 equals -4 plus 6 minus 1 times d, or -39 equals -4 plus 5d. 6 minus 1 in parentheses you do first. Add 4 to both sides. -35 equals 5d. Divide by 5, -7 equals d. A sub 1 plus d is a sub 2, right? So -4 plus -4 plus -7 is -11, plus -7 is -18, plus -7 is -25, plus -7 is -32, plus -7 is -39. It checks. So here are the first 5 terms in the arithmetic sequence. All right, put your life jackets on. We're going in the deep end. Woohoo, yes, here we go. I can hardly wait. I'm my own cheerleader, I know, because nobody else is out there going, yes, we're doing math. Isn't it great fun? Oh, I'm so sorry, Norma. You're filled with tears of laughter. All right. Do you know what a mean is? And I'm not talking about somebody that's not nice. but a mean is like a middle value. So like the mean between 1 and 5 would be 3. It's the middle value, okay? This says insert a given number of arithmetic means between the numbers. Well, for instance, if I want one arithmetic mean between 1 and 5, that would be 3. But what if I've got, let's say 1 and 7, and I want 2 arithmetic means? Okay, so a sub 1 is going to be 1, a sub 4 is going to be 7. I need 2 numbers in here such that each of these are equal distance. Okay, so that would be to find 2 arithmetic means. Well, let's see how we can do that. All right. Again, it says insert the given number of arithmetic means between the numbers. We are to insert 2 arithmetic means between 2 and 11. So the first term is 2, okay? We're supposed to insert 2 arithmetic means between 2 and 11. So that means we've got 2 in the middle, and then we get to 11. Again, do you understand how I knew that 11 was a sub 4? Because we had the first term, 2 in the middle, and then the last term. All right? This is just like the last few problems. Once we've set it up, we just needed to know that 11 was a sub 4 because we're putting 2 arithmetic means in the middle. We're going to use this formula. And we're going to say, well, a sub 4 is 11, but a sub 4 is also a sub 1 plus 4 minus 1 times d. Is it starting to look familiar? So we've got 11 equals 2 plus 4 minus 1 times d. 11 equals 2 plus 3d. Subtract 2. 9 equals 3d. Divide by 3. d equals 3. 2 plus 3 is 5, plus 3 is 8, plus 3 is 11. Now, you can sit there and trial and error it all you want and come up with those numbers without doing all this. But in your process, you actually are doing this. You're not just doing it formally. And it's going to take you a long time if I've got huge numbers. So learn to do it using this method. Don't try and shortcut it. Good luck when you get larger terms to find. Okay. All right. Let's see. Next example. We're to find 3 arithmetic means between 20 and 30. So a sub 1 is 20. We're to find 3 arithmetic means between 20 and 30. So now my last term is a sub 5 because I've got the first term, 3 in the middle, and my last term. Okay? So a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub 5 equals 30. A sub 5 equals a sub 1 plus n minus 1 times d. So therefore this equals that. 30 equals 20 plus 5 minus 1 times d. 30 equals 20 plus 4d. Subtract 20 from both sides. 10 equals 4d. Divide by 4, d equals 5 halves. I deliberately picked this one for you, Crystal, because you said, well, we get fractions. Here they are, okay? So if anyone gets a headache, it's your fault because you were asking about fractions. Okay, so what do I do with a common difference? I add it. So a sub 1 is 20. A sub 2 is going to be 20 plus 5 halves, okay? What I'm going to do is I'm going to make this all a fraction. So 20 plus 5 halves is like 20 over 1 plus 5 halves, right? What's the common denominator? It's a 2. So I'm going to multiply this by 2 over 2, and that's going to give me 40 halves plus 5 halves, which is 45 halves. Okay. Any questions about how I got there? All right. A sub 3 is going to be 45 halves plus 5 halves, which is 50 halves, which is 25. A sub 4 is going to be, let's see here, I'm going to erase this so I can write it again. People are panicking. I hadn't finished writing it down. Go back and check the video, which is 25 plus 5 halves. We're going to multiply 25 by 2 over 2 to get a common denominator. So we get 50 halves plus 5 halves, which is 55 halves.
When we go to submit it, would we have to simplify it, or are we leaving it as improper fractions?
Okay. Recall from previous assignments, WebAssign doesn't do well with mixed numbers. So if it's a whole number, that's great. But if it's a fraction, don't rewrite it as 20, what is that, 27 and a half. Leave it as an improper fraction. Yeah. Just avoid mixed numbers altogether in WebAssign. All right. And then what have we got? 55 halves plus 5 halves is 60 halves, which is 30. So, and let's see, we'll get rid of this chicken scratch there. And let's see, what did they say? They said, insert the given number of arithmetic means. And so most likely what it'll want is just those 3. And again, this is where people will get it wrong. It'll ask for the 3 arithmetic means, and people will list all 5 terms when all they're asking for is those. So be careful, read the directions when all else fails. No, read them first. Okay, now, all of these problems have been based on this formula. This is a formula you should memorize, but when the test comes along, you can have that formula in front of you on a card if you need it, okay? There are some other problems in this section that don't use this formula necessarily, but in those problems, they specifically give you the formula they want you to use. So let's look at some of those. For instance, this problem says, using the formula a sub n equals 4n minus 1, find, let's see, write the first 5 terms and then the specified term, okay? And the specified term is a sub 40. So we know a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 40, okay? In fact, here, let's get rid of that. So we're going to use this formula, not that other one we've been using, to find the first 5 terms and the 40th term, okay? So a sub 1 is 4 times 1 minus 1, which is 4 minus 1, which is 3. I'm just plugging in right there, the 1, okay? A sub 2 is 4 times n minus 1, which is 8 minus 1, which is 7. A sub 3 is 4 times n minus 1, which is 12 minus 1, which is 11. A sub 4 is 4 times 4 minus 1, 16 minus 1, 15. A sub 5 is 4 times 5 minus 1, 20 minus 1, 19. A sub 40 is 4 times 40 minus 1, 160 minus 1, 159. Okay. Any questions about this one? All right, let's take a look at one more. Let's see here. This one says a sub n equals negative n squared. Find the first 5 terms. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and the 20th term. All right. Now, order of operations is important. Negative n squared. The base is the n. So you're going to square the n and then apply the negative sign. So for instance, let's say I've got this problem. That's 3 times 3 with a subtraction or negative sign in front of it. But if I had this, that would be positive 9. But over here, the base is the n. So you square the n and then apply the negative sign, okay? Careful there, order of operations. So a sub 1 would be, let's see, a sub 1 would be negative 1 squared, which is negative 1. A sub 2 would be negative 2 squared, which is negative 4. A sub 3 would be negative 3 squared, which is negative 9. A sub 4 is negative 4 squared, which is negative 16. A sub 5 is negative 5 squared, so negative 25. A sub 20 is negative 20 squared, which is negative 400. But again, you're squaring it and then applying the negative sign because of order of operations. All right. So 14.2, just to let you know what's coming up. So this is Thursday, right? Friday, tomorrow, we're going to do 14.3. And then Monday, oh, and also notice if you look at your schedule, Friday, September 24th, it says 14.3 and test review material. So you're going to do actually 2 sections over the weekend, 14.3 and the review session. On Monday, we'll have a Zoom meeting, and what we'll do is we'll review for your test. Then Tuesday, there will be no class meeting. Tuesday, you have all day to take your test, though once you start, you just have 75 minutes. It's not like you can start at 9 in the morning and finish at 9 at night. But my point is, there's no class meeting on the test day. I will be there for my office hour at 1:15. But now, here is the bad thing that a lot of students do. They don't want to do 2 sections in one day. So they do 14.3 on Friday, okay? Monday comes along, and since the review session isn't going to be too late till Monday at 11:59, they do the review Monday, after our review session. But then they have a bunch of questions and they panic and they email me, and I'm like, no, you were supposed to do it over the weekend. The review session is for you to ask about questions that you already did, okay? The point I'm trying to make again is keep up with the schedule. Don't do it the day it's due. Do it the day it's assigned, so that if you have questions, you have time to finish the ones you couldn't do. Okay, I know, nag, 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 nag. All right, anyway, that's it for today. I'm going to stop the recording and